All right. So can you guys see my screen now? Hello?
Sir.
Can you see my screen?
Hi, sir.
Hello.
Yes,
Yes,
sir.
sir.
Hi, sir. Good afternoon.
It's good. All right. So before we'll start with our discussion with the module for number systems, so I just would like to know if you guys have a question or clarification regarding with our discussion or with your laboratories. Lab 1, I think it's super easy. Lab number 2, anyone who has a question? Lab number 3, lab number 4. Okay, no question. So everything is clear so far from the instruction of the laboratories. All right. Okay, how about giving me a thumbs up if you guys don't have a question? Okay, if everything is okay, just give me a thumbs up. Okay, good. All right, very good, very good. Okay, then. Okay, so if you guys don't have a question anymore, then let us now start with the discussion for the module 4. Okay, so the topics that we will discuss under module 4 is decimal, binary, octal, hexadecimal, and then n-base system. Okay, and then we'll also talk about number conversion operations, sign numbers, and then computer codes. All right, so let's talk about number systems first. So just to give you guys a brief idea, okay, just a heads up on what are those number systems. Okay, let me just open my notepad. What's happening? My computer is lagging. All right. So under number systems, we have decimal, wherein when we see decimal, it's actually key from our hands or our fingers to be exact. So decimal has 10 base or 10 characters. Okay. So base 10. Call this one base 10. Okay. And then this one has 10 characters, of course. But then since we are going to start with 0, so this one is only ranging from 0 to 9. Okay. So starting from 0, and that's already your first character up to 9. A total of 10 characters. Okay. Next one is binary, which is very, very obvious already from the word by. So we only have 2 characters in here, or this one has a base of 2. Okay. And then of course, since it only has a base of 2 or it only contains 2 characters, so that's only 0 to 1 or 0 and 1. Okay. And the next one is octal, okay, which has a base of, so from the word octa, so of course it has a base of 8, or it contains 8 characters, wherein of course it's only ranging from 0 to 7. Okay. And then for the hexadecimal, okay, this one is just twice of the octal, hexadecimal, wherein of course this one has a base of 15, 16. And then of course this one is ranging from 0 to 15. All right. So I hope I was able to give you guys an idea what are those names of number systems. So maybe binary, you guys are always hearing about binaries. So maybe you already have an ideas about, binary only contains zeros and ones. But maybe for the octal and then hexadecimal and then decimal, maybe not so much. But anyway, I just have a question. So why do you guys think? Why do you think learning about a number system is important? So why do you guys think we need to study or learn how number systems work in our computer? Anyone would like to share their ideas or thoughts regarding with this one? All right. So no one would like to answer. Okay, let me just choose one randomly. Okay, Mr. Kenneth Palpeg. Hello, are you there, Mr. Kenneth? All right, so maybe he's not around. How about you, Miss Shian or Shin Sembrano?
Yes, sir. No idea po.
No idea. Okay, how about the others? Anyone? We have volunteer. Okay, Mr. Van Luther.
Sir, siguro yung pagkakaintindi ko sa kaya natin pinag-aaralan yung number system is para makuha natin yung pinaka-basic na knowledge sa pag-i-encode po.
But not really. Okay. So, learning about number systems, maybe it has a 1% contribution when it comes to programming. Okay, so in fact, you will not be able to use this one. Well, maybe some, 0 to 5%, yeah, 1% to 5%, but not that much. So the only reason why you need to study about number system is because this is how our computer reads or process our data. Okay. All right. So there is an answer coming from Miss Joma Salen Sanga. So in my opinion, only I think we need to learn number system so we know what to install in our computer or what hardware upgrades. No, 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 no. You don't need number system for that. Okay. All right. So basically, uh, we only have binary actually. Okay. When it comes to processing everything. Okay. Or how our CPU process datas in our computers. Okay. So as you guys may all know, CPU is the central processing unit, and then it can only read two number. Okay, a combination of zero or one or zero, or it could be one only, zero only or one only. So you can actually come up with 4-bit, 8-bit. So when I say 4-bit, it contains four characters, meaning it could be four zeros, four ones, could be two zeros, two ones. So depending on the combination. So we have a lot of possible uh, combination when it comes to four numbers. Even more if you have 8-bit. Even more if you have 16-bit or 32-bit. So we're just talking about bit. Okay. What about more if you're going to talk about the word byte? Okay. What about more if we're going to talk about megabyte? Okay. Next one is gigabyte. Okay. Next one is tera. Okay. So right here, we're only dealing with, hundreds of instructions, maybe thousands up to here or up to million, and then millions to billions, and then millions to billions, and then billions to trillions. Okay. So as you guys can see, we have a lot of possibilities that we can do to our computer. So that's the limit for now. I guess what is next to Terra? And I forgot. But there is already a new technology wherein there's much more larger space than terabyte. But yeah, anyway, let's go back with the bit right here. So our CPU can do many tasks. So you can say that it can process thousands of instruction, uh, hundreds of thousands of instruction, and so on and so forth. So wait a second, guys. Okay, so going back to our discussion right here. So sorry for that because my cat is scrapping, how do you call that one? Scratching my legs. Anyway, so going back to the CPU, as I'm saying, so this is how our computer processes the data. Okay, so it deals with bit or binary, zero combinations of uh, binaries. Okay, so it could also read octal, or it could also read hexadecimal, or it could also read decimal. But mostly, binary is already enough. All right, so that's how our computer reads the data. So for example, as I'm pressing anything on my keyboard right now, so as you guys may all know, our computer doesn't read letter A as letter A. Okay, it reads that one as a combination of binary. So for example, if you guys are going to take a look on our ASCII code right here, so letter A, capital letter A. So take note, capital letter A is different to small letter a. So in here we have a decimal value of 65. So 65, if you're going to convert this one into binary, okay, you'll be able to form, okay, just wait a second. So let's start with 8-bit, 8-bit binary. So 1, 2, 4, 8, 16, 32, 64. So 1 and then 1. Okay. So basically, uh, as I was typing this letter A, my computer is now reading this kind of number. Okay, 01000001. Wherein our computers is the only one who can understand those kind of numbers. So in his uh, CPU, okay, he reads letter A as this kind of number. All right. So if you want to put operation, let's say 65 plus 43. So this is another uh, character wherein it's a positive sign. So 43 is 11632 and 1632. Okay, we need 8. Aray. 32 plus 8, 43, 0, 1, 1. Okay. So in here, there is another operator wherein this is a positive sign. Okay, wherein let's say you want to put another uh, let's say number wherein you wanted to add that one into this letter A, then you can do that one. Okay. Anyway, the point here is this is what our computer is reading. Okay, not exactly letter A or not exactly plus sign. All right. So yeah, that's it for the short overview on what are the number systems in our computer. Okay. All right. So let us start now with the decimal number system. So as I have mentioned a while ago, this one is derived from the Latin word finger. Okay. So we have 10 fingers in total, so a total of 10 characters, or we call this one base 10. Okay, wherein of course it's ranging from 0 to 9. All right. And then we also have here binary, wherein of course we have zeros and ones, wherein 0 indicates that it's off or inactive, and then 1 is for on. Okay. So each digit is called a bit. So one character is 1 bit. So it's 1 is to 1. But we have another unit here, or another name of size, wherein 4 bits is equal to 1 nibble. So maybe this is your first time hearing about nibble, because what you guys are always hearing is the word bit and then the word byte. Okay, and then next to that one is kilobyte, and then next is megabyte, gigabyte, and so on and so forth. But in here, 2 nibbles or 8 bits is equal to 1 byte. Okay, and then 2 bytes is equal to 1 word, and then 4 bytes is equal to double word. Okay. So you will see here the graph wherein we have 32 bits in total, or 32 characters. Okay, wherein we have here the lowest bit and then this is the highest bit. and then the entire 32-bit is equal to one double word. Half of it, which is 16-bit, is one word, and then another half of word is 1 byte, okay, which is equal to 8-bit, okay, and then 4-bit is one nibble, okay. Next one right here is a representation or the equivalence of the decimal into a binary, or vice versa, binary to decimal. Wherein, as you guys can see right here, we have 0 is equal to 0, 0, 0, 0 in binary. And we have 1, and then it's equal to 0, 0, 0, 1. And then 2 is 0, 0, 1, 0. And so on and so forth until you reach 15, which is equal to 1, 1, 1, 1. So anyone here who knows how to read binary? Anyone? All right, so I guess none. Anyway, so let me just discuss this one on how did we have those kind of equivalents wherein 0 is equal to 0, 0, 0, and then 1 is equal to 0, 0, 1. So in here, when we say binary, okay, when we say binary by default, okay, this one contains 2 characters only. But we always start with 4-bit when we see binary, okay? Say 0, 0, 0. So this is your lowest bit, and then this is your highest bit. And then each one of those characters or each one of those bit represents a value, okay, or a number. Wherein this lowest bit right here represents 1, okay, and then the second lowest is 2, and then the third lowest is 4, and then the highest bit is 8, okay. So from lowest to highest, all right. So that is the reason why when we say 0 in decimal, so let's say this is your decimal, and then this is the binary part, okay. So 0 right here, of course everything is 0. So again, 0 represents inactive or off. So once you turn on one of these values, so it will be counted now as a value of that entire combination of number or combination of binary. Like for example, if we have 1 right here, so if you're going to get the equivalence of this 1 into binary, so it would be 0, 0, 0, 1. All right. So that's how we've got the value of 0, 0, 1. If we have 2 right here, then it would be 0, 0, 1, 0. Okay. So as you guys can see, you only need to activate this second lowest bit because you're only getting the value of 2, okay, which is now equal with the decimal 2. If we have 3, then we have to activate 2 and 1. So 2 plus 1 is equal to 3. So 0, 0, 1, and then 1. All right. So if you're going to proceed, then 0, and then 1, and then 0, 0. So you only need to activate 4. So in here, to make this one for you, easy to memorize, okay, or familiarize. So starting with the lowest bit. So the value of that one is 1, and then just keep on multiplying uh, it by 2, okay, for you to be able to get the second lowest bit, and then the third lowest bit, and then the fourth lowest bit. So times 2 will give you 2, and then multiply it again by 2 will give you 4. Multiply it again by 2 will give you 8. All right. So if you want 8 bits, okay, let's say 8 bit. So this one is 1, 2, 4, and then this one is 8. And then of course the next one to that is 16. Just multiply this one by 2. So just keep on doubling it. And then this one is of course 32. Okay. And then this one is 64. And then the last one is 128. So of course it's not limited to 8-bit only. It's not limited to 16-bit, 32-bit, 64-bit, 128-bit, 256-bit. Okay, so you can have more. Okay, so if there's another 1 bit right here, wherein I just keep on doubling is 1. So 128 times 2 is 256. Okay, 524, 1028, and so on and so forth. Okay, but mostly it's up to 8-bit only, especially if you're still learning about computers, or you're just learning about how the computers process the instructions. So up to 8-bit only. So I think 9-bit or 10-bit is already too much. Having an example of 8-bit is already enough. Okay, so until you will reach the value of 16 right here, 15 only. Okay, so this one is 1111. Okay, so 8 plus 4 is 12, plus 2 is 14, plus 1 is 15. Okay, which is the same now with this one. So were you guys able to follow, and how did we get those equivalents from decimal to binary? Hello, are we clear so far? Okay, that's good, Mr. Raymark. How about the others? Okay, good, Mr. Moknangan. Okay, Mr. Bayawa, Miss Eunice. Okay, Miss Selayan. All right, very good. Okay, so I hope the others were also able to get this one. All right, so let us now move on to the next one. So that's how we get equivalence, okay, from decimal to binary. All right, so we also have here octal number system, wherein again, of course, octal contains 8 characters, but of course, it's only ranging from 0 to 7. Okay, and as you guys can see right here, yes, it's ranging from 0 to 7, but it jumps right away to 10 to 17, and then 20 to 27, 30 to 37, 40 to 47. So if you're going to take a look on that one, so that doesn't contain 8 and 9, or 18 and 19, or 28 and 29. Okay, so let me just explain this one on why do we have that kind of sequence when it comes to octal number system. All right, so let me just have the decimal right here. And then let's say we also have octal right here. Okay, so for the decimal, so no problem. That's it's the same on how we count with our normal mathematics. But in here, of course, we're going to start with 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So let's have up to 35 maybe. 27, 28, 29, 30, 31, 32, 33, 34, 35. All right. And in octal, so 0 to 7 is the same when it comes to decimal. So 0, 1, 2, 3, 4, 5, 6, and then 7 is the same. However, once it reached the value of 8 in decimal, the equivalence of that one in octal is already 10. All right. So next to that one is, of course, 11, and then 12. Okay. So after that, uh, after that, so just keep on proceeding. So just skip 8 and 9. So 12, 13, 14, 15, 16, and then 17. And then again, we don't have 18 and 19. So after that, we'll have 20. So just keep on counting up to 27. So 21, 22, 23, 24, 25, 26, 27. And then in here, we have 30, 31, 32, 33, 34, 35, 36, 37. And then in here, we have 40, 41, 42, 43. Okay. So if it asks you what is equivalence of, let's say, 26 from decimal to octal, then you would say 32. Okay. So my only tips in here is maybe familiarize, maybe not memorize, because you'll only maybe get confused if you will memorize this one. just to get the idea. Okay, so in octal we don't have 8 and 9. All right, we don't have 18, 19. We don't have 28, 29, 30, 39, and so on and so forth. Okay, until you reach 100. Okay, so that's the reason why we have this kind of sequence in here. Okay, so 15 is equal to 17, and then 16 is equal to 20. So let's check whether this one is correct or no. So in here we have 15 is equal to 17 in octal. There you go. So 15 right here, and then 17 in octal. And then 16 right here in decimal, 16, and then 20 in octal. All right. So don't you guys worry. Maybe ranging from 1 to 30 of decimal is already enough to, you know, get the correct answer when it comes to maybe your quizzes and your activities. So you won't reach up to 40 or 50. So maybe up to 20 or up to 30 only. Okay. And the next one right here is hexadecimal. Okay, how many minutes do we have more? Okay, we have 8 more minutes. Okay, hexadecimal is of course 16th base, and then it's ranging from 0 to F. Okay, so I mentioned a while ago that this one is ranging from 0 to 15. However, once it reach 10, okay, to 15, this one now is equal to a certain letter. Okay, wherein 10 is equal to capital letter A, and then 11 is equal to capital letter B, and so on and so forth, wherein up to 15 is equal to a capital letter F. Okay, and also we have this kind of sequence. So 0 to 9, A to F, 10 to 19, 1A to 1F, 20 to 2F, 30 to FF, and so on and so forth. Okay, so let's use our previous example. Let's just add another range of number, hexadec, so that we can align that one to our example in decimal and octal. So in here, 0 to 9 is the same, so no problem. There you go. Oops. Let me just align this one. So yeah, so 9 in, okay, let me just transfer this one. So decimal to hexadecimal, so they're the same, 0 to 9. But once it reach the value of 10, this one now is A. Okay, this one now is B, C, D, E. Let me just align this one. E and then F. Okay, and then in here, once you've reached the value of 16, so you have to continue this number right here. Wherein, of course, after 9, we have 10, 11, 12. So just count 10 to 19. Okay, 13, 14, 15, 16, 17, 18, 19. Okay, so let me just align this one. I think that's already good enough. And then in here, once we're done with 19, so as you guys can see, the pattern is, after the 0 to 9, we have letters. And then after 10 to 19, we have letters again. Okay. So again, just continue this one. So instead of, just A only, we have to add 1. Okay. 1A, 1B, 1C, 1D, 1E, and then 1F. So again, let me just align this one. Oops, I need more space. There you go. And then once you reach F, then you have to go back to this previous sequence of number. Wherein, of course, after 19, we have 20, 21, 22, and then 23. All right. So here are the questions, sample questions that you might encounter. So let's say, what is equivalence of uh, 20 decimal into hexadecimal and octal? So in hexadecimal, it's 14, and in octal, it's 24. Okay, so you might not get, uh, a sequence from that. However, once you've learned the uh, idea of octal and hexadecimal, then you can have a list of something like this. Okay, for you to have an easy reference when you've encountered a value of 29 in decimal and then you wanted to get the value of it in hexadecimal and in octal. Okay, so with the octal, I'm not sure what is the correct arrangement now since we've arranged the decimal and hexadecimal. But anyway, so yeah, those are your equivalents. So were you guys able to get the idea regarding with hexadecimal and octal? Right? So very good, Mr. Raymark. How about the others? Okay, very good, Mr. Miss Kyla. Okay, good, Miss Ayan. All right. So how about the others? I'm confused. Ha ha ha. Okay, that's okay. That's okay since this is your first time. So, I just at least get the idea, okay? Uh, if you cannot understand, my explanation in here, we have a lot of, I've included here a lot of uh, other references came from YouTube. Okay, so you can watch this one on how to convert a decimal to binary, and then, introduction about number systems, talk about decimal, binary, octal, and then hexadecimal. All right. So that's a good thing that most of you were able to get the point of decimal to hexadecimal and then octal. All right, so how many minutes do we have more? So 2 minutes. Okay, so let's continue. Okay, so here are the things that you can do. Of course, you can convert binary to decimal, octal to decimal, hexadecimal to decimal, and then n-base decimal. So going back to our number systems. All right, so let me just go right here and let's move this one. Okay, so of course, if we have base 10, base 2, base 8, and then base 16, we could also have base 1, of course. So not only base 1, of course. So it can range up to 16. Sorry, 15. Okay, a base of 15. So let me just copy this one and then paste it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have base 1, we have base 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Use. Stop it. 12, 13, 14. We need one more. So we have here. Alright, cool. Alright, so wait a second, guys. Alright, so we have base 1 to up to 15. Okay, so going back to our normal number systems, we only have 4 to be exact. So base 4 is, sorry, base 2 is binary. It's the binary already. And then base 8 is octal. And then base 15, we need one more, 16 actually, base 16. Okay, base 16 is hexadecimal. Okay, and then 10 is of course decimal. Okay, so the others in here, as you guys can see, base 1, 3, 4, 5, 6, 7, 9, and so on and so forth, are called the n base. So anyway, we'll just talk more about this one later on since we don't have enough time anymore. So we'll just continue this one on part 2. So goodbye for now and see you guys later.